F and then hyphen G H I J, right? So capital I is there, small J is there. So we don't really care about whether it's a capital letter or small letter. Now what you need to do,
చూసి ఏమంటే బయట
right?
ఏమైనా
So
చేశారేమో
what is the
అనుకున్నా.
answer? Let us also bring the
ఇప్పుడు
answer.
అర్థమైంది. సరే అయితే నా 2 ఫొటోస్ పెట్టు, ఫస్ట్ 2 పేజెస్ అని.
Okay. So
సరే
for
అన్న
this,
అయితే
the answer is this one, right? This is the answer.
ఏంటది అసలు
Now
యాక్సెప్ట్ చేసాక
let's
ఏం
write the
చేయాలి?
answer also. The answer is J I H. So
అవునవును,
it's actually
చేసి
J
చేసి
hyphen I H hyphen G hyphen F E hyphen T C B E. Now how exactly we got to this answer, right? Now let's see the story. The story is, in this string you can see normal characters, which means alphabets, and you can also see hyphens, right? Now what they are saying is you should not really reverse the hyphens. Okay, hyphens has to stay in the place where they were earlier, like this. So hyphens, you can observe that hyphens place isn't changed, only the place of the alphabets is changed. These are the alphabets, right? So let me color it in a different color. Okay, only alphabets must be reversed. Okay, now whether these alphabets are reversed or not, let us try to check. Okay, so first we have A and J, right? So A and J are basically, A is an alphabet, J is an alphabet. So what you need to do is you need to reverse. You need to make J comes to the place of A goes to the place of J. Correct, that works, right? But now if you try to look at the next two characters, for example, if you try to use the 2-pointer technique, let us write the indexes first. 1 2 3 4 5 6 7 8 9 10 11 12. Now you know the 2-pointers approach, right? In 2-pointers approach, you know we start I value here and J value. Now what we generally try to do is we will check if the characters at I and J index, we will try to swap them. We will try to swap I and J, and then we will try to move I to left, right, and move J to left, and then we will swap this one and this one. But here is the catch. Unfortunately, you can't simply swap this hyphen symbol with I value, because hyphen is not an alphabet, right? They only want us to reverse the alphabets. They don't want us to reverse the special characters or even numbers. If numbers are present like this, if there is a 0, we should not reverse it. Then how can you try to reverse this using 2 pointers? Well, this is where we don't actually try to move I and J at the same time. Now first what we will do is we will try to check whether the character at ith index and character at jth index, are they both letters? Letters means, are they both alphabets? You can see the character at jth index is an alphabet, but not the character at ith index, right? Now in that case, instead of swapping them, we already have a character at jth index, right? This is okay for us. But the character present at ith index is not an alphabet. This is not okay, right? So when you find that the character present at ith index is not an alphabet, then you move only I. You don't move J. Now see, at ith index you have a character, and at jth index also you have a character. When both are okay, then you will try to swap. How do you swap? I comes here and J comes here, which means B comes. So since we did not touch the first index contain hyphen. You got the point, guys? So whenever you swap both ith index and jth index, you will only swap it when you make sure both indexes contains a letter. A letter means alphabet. Then you can move I and J at once. I moves towards right, J moves towards left. Now see, this is also okay, right? Ith index contains C, which is a character. This is okay. And jth index also contains a character. This is also okay. Then what do? We swap. H comes to the place of C. C goes to the place of H. So you can see we are slowly constructing our output, right? Slowly we are reversing this. I hope you got the point. Now we try to move I, and then we try to move J. Done. But now we encountered the same problem. What is the problem? At jth index, it's okay because we have letter. G is a letter, right? But ith index, again, you encountered a hyphen, which is not okay. Then what do? Without moving j, you only move I. So here you need to come up with the code, guys. Code means when you are moving I without moving j, and when you are moving only j without moving I, and when you are moving both. So there are three conditions, right? What is the first condition? First condition, when to move only I. When to move I? So you can answer this very easily. If ith index doesn't contain a character, then you only move I, right? A character means when it doesn't contain, in specific you can say when it doesn't contain an alphabet, right? Right. But it doesn't contain alphabet. Now, second question. When to move only j. So when to move j? If jth index doesn't contain an alphabet. Now when to move both? This is the third case, right? When to move both? You can move both if ith and jth index are both alphabets, right? First look at here. At ith index you don't have an alphabet, but jth index is an alphabet. Then there is no point in moving j, right? If you move j, you miss this alphabet. You did not swap it, right? So in order to reverse, we need to swap. We have seen this, right? So that is why what you need to do is you only need to move j, because you are hoping that in the further indexes maybe I will find an alphabet. Now you found it, right? Now you can see at ith index also there is an alphabet. Then what do we try to do? We try to swap g to the place of d like this and d to the place of g like this. Remember, we did not touch the fourth index, right? So that's why fourth index still contains hyphen. Now, since both of them are alphabets, we moved both pointers, right? Then you can move I here, you can move j. See, why am I moving I and j? You can ask this question because you already processed d and g, right? That means you swapped their roles. Okay, then you can move I as well as j. Now you fell into another case, right? What is that case? Now you can see jth index. Jth index is not alphabet, right? But ith index is. So in this case, what do? Instead of touching this, you just decrement j like this. So you keep this place of hyphen like this. Now both are okay, right? Ith index contains character e and jth index contains e. Now you try to swap f to the place of e to the place of f. See, we got the answer. Answer is j hyphen ih hyphen gfe hyphen dcp. How many of you understood this, guys? So did you understand when to move each point in the two pointers technique? So can you convert this into code? Using two pointers technique, can you solve the above problem and send the screenshots if you haven't already? The idea is to figure out when to move which point, right? So we try to move the pointer I and the pointer j both at once if both indexes contains alphabet like this. See, when you started out first, 0th index contains alphabet, first index also contains alphabet, sorry, last index. Then you process the swapping. Swapping means a goes to the place of j comes to the place of a. You swap and then you move forward both. This one moves forward and this one moves backwards. So you move both pointers, right? But whenever at ith index you do not really have an alphabet, then you just move it in the hope that you will find any alphabet in the next indexes. Yes? So will you open this problem and write the code? The problem is sent in the chat box. It's called as reverse only letters from LeetCode. It only has 67% acceptance because implementing this could be a little tricky. So this is the problem, guys. I am not going to give you much time. Like I'm going to give you 5 minutes of time. and in the 5 minutes try to write the code. So this is the process. The process is when to move I, when to move only j, and when to move both I and j. Okay, if you are trying to solve this problem in Java or Python, you may have to convert the given string into a list of characters in Python or an array of characters in Java, which means you have to convert it into a character array, because string itself in Python and Java is immutable. So which means you cannot really perform the swapping. I told you the swapping, right? The swapping cannot directly be performed on strings in Python or Java, right? So what you need to do in Python, if it's Python, if you need to convert the given string into a list of characters like this, lst equals list of string, that is going to convert the string into list of characters, right? But if you are using Java, in Java you need to take a character array that's called char arr equals, you need to use one method on strings called start to char array. So I hope some people are using Java here. If you are using Java, first you have to make sure you convert this string into an array of characters so that you can perform the swapping I mentioned, right? And in this program internally, you have an extra task. That extra task is you need to somehow come up with the logic on how to identify whether the given character at a particular index is an alphabet or not. It can be easily done in Java by just checking if this alphabet is in the range 65 to 90 or is it in the range 97 to 122. If this alphabet is in any of those two ranges, it's an alphabet, right? Otherwise, it's not. So because all alphabets are either uppercase or lowercase, uppercase are from 65 to 90 and lowercase are from 97 to 122, right? So if you don't use the two pointers approach, you may have to take out all the alphabets from the given string into a new array, right? And in the new array, you can try to reverse them using a two pointers technique. And then you would have to put the elements back into original array. So it will be a 3-step process, right? I will also show you that for those who are wondering. So if you don't want to use two pointers technique, especially by confusing like this, what you can do is you can take a new array, and into this new array you will only try to bring out all the alphabets, right? So this is alphabet, this is alphabet, this is alphabet, DEF for alphabets, and also GHIZ, right? So you only try to bring out the alphabets, and once you brought out the alphabets, now you try to reverse this array, like how J comes to the place of A goes to the place of J. This one doesn't require you to check whether both of them are alphabets, right? Because earlier we have to check, we are working in the original string, which could contain non-alphabets also, which could contain special characters and numbers. But since you only extracted alphabets from the string and stored it in a new string or a new array, now you can directly interchange, right? First last, second and second last, third and third last, fourth and fourth last, like this. And then you can interchange fifth and fifth last. Now, but another step is needed. What is this another step? You reversed these alphabets in the new array, right? In the dummy array you have taken. Now you need to put it back by keeping these special characters or non-alpha characters at the same place, right? Which means again you need to run a loop on this. And when you are running the loop, you will identify whether this particular index is an alphabet. If it is an alphabet, you will try to pick one alphabet from this dummy and place it here. So J will be placed here. And you need to maintain an extra loop, right? Extra loop to run here. You have to use maybe K to run a loop on this reversed version of the alphabets. And then you move K. So from kth index, now you don't bring it here because it is not alphabet, right? Hyphen is not alphabet. So you just move forward. Now B is an alphabet, right? So there you will bring out another character. And then you will bring H here. And then you will bring G here. And FE here. And then DCBA here. So that also gives you the output, right? JIH, GFE, DCBA. That's what you would have to do if you don't use two pointers. In C++, you don't have this problem. In C++, strings are by default mutable. So mutable means you can directly apply this exchanging technique on the strings directly. You don't need to convert it to any character arrays or list of characters like you do in Python. Okay, so I have given you enough time and I hope some of you are trying. So for those who are just here, sir, I will try to learn how this works. First step, we are trying to convert the string into character array. I am showing it in Java. And why we need to convert a string into character array? Because by default, strings are immutable. If you take a string like this, for instance, if you take the given string itself, A, B, C, D, like this, you can't simply interchange the last character and the first character. This interchanging is not possible because strings are immutable. Now, for the sake of this interchangeability, we need to convert this into an array of characters like this: A, B, hyphen, C, D. Luckily, we don't need to run a loop to do this. In Java, we have a method that will help us to do this. So you just use the string name and write the method toChar array. That will give you the character array. Okay. Now on the character array, we will try to use the two pointers approach. Right. What is the two pointers approach? We know how to use it, right? We see in the palindrome program. First, we will try to start one pointer from 0th index, that is the leftmost, and another pointer from the last index. So last index can be obtained using length -1. Right? This is an array. If you want to find out the length using character array, you have to write like this. If you want to use the string, because both will have the same number of characters, right? Basically, if string contains 10 characters, character array also contains 10 because we're obtaining the character array from string only, right? Now, what you will try to do? Same story. You will try to run the loop as long as I less than j. But here is the catch. The catch is we are not going to directly swap like we did in normal reverse. In normal reverse, we don't check any conditions, right? We would simply take a temporary variable and try to write a of I and set a of I to a of j and set a of j to temp. This is how we try to swap, right? But this won't work here. The reason is we only need to reverse the alphabets. We should not reverse an alphabet and a hyphen or a special character. And we should not also reverse an alphabet and a number like 0, 1, 2 digit. So that's the reason. First, what we need to do is we need to check if the characters at ith index and jth index, if those characters are both alphabets. If and only if they are both alphabets, then we can simply swap them, right? So to check whether the given character is alphabet or not, we can try to write a static method here. Public static. Since we are checking, I'm going to write the data type as Boolean. What we are going to check is alpha, right? Is alpha means whether it's an alphabet. So if you take a character ch, how do you check if it is alphabet? I told you two possibilities. Character can be greater than or equals to a, and character can be less than or equals z. That means it's an uppercase character, right? It's in the range a to z. This is one possibility. Or what is the other possibility? Character can be greater than or equals a and character can be less than or equals z. Now this is the range small a to z. In these both cases, we can say it's an alphabet, right? Now we are going to return this. So please note that I am not returning character. I am returning Boolean value. How Boolean? See, this is a logical expression, right? We combine two relational expressions with logical end. And this is also a logical expression. And this is also a logical expression, right? So we know that comparison or logical operators, they will give which type of values? True and false values, right? So this will give you true if the given character is either in A to Z capital or in A to Z small. That means it's an alpha. Now what I will try to check? I will try to check if both are alphabets. So what does that mean? If array of I, if I send it to is alpha method, it should give me true. So this means ARR of I, the character at ith index is alphabet and jth index is also alphabet, is alpha of array of j. If both are alphabets, then only we try to swap. How do you swap? Simply take an extra character, char temp equals array of I, and array of I will be swapped with array of j, and array of j will be filled with temp. That's it. Now, what if only one of them is alphabet, but not the other one? Then how do you check it? Now we will go to else if. Else if only one of them is alphabet, I will check it. Is alpha of array of I. That's it. Now you may ask, sir, if is alpha of array of I is also written here and also written here. So how do you know that this will only check whether array of I is alphabet? See, you can think of this, right? When this will fail? Well, this will fail, the above one. This will fail if either this one is not alphabet, which means ith index character is not alphabet, or jth index character is not alphabet, right? But we don't know because of which one is it failed. So that's why I'm checking is alpha of array of I. Now, if is alpha of array of I is true, that means j is not alphabet, right? In that case, what you will try to do? Decrement j. That's what I told you, right? Look at this. Here, if you find that ith index is alphabet, like this, ith index is alphabet, but jth index is not alphabet, then which one you should move? You have to keep I here only, but you need to move j forwards, because you are hoping that you will find a match. You will find another alphabet so that you can swap these two. So we moved j. Where is the program? Yeah, it's here, right? So we are moving j. In the other case, what we are trying to do? We are trying to move I. Right? But if both are alphabets, then we are trying to move I plus plus, j minus minus. Okay. So here, what if both are not alphabets? That case will also come, right? So it's better to write another else if to check is alpha of array of j. Then if j is alphabet, we need to move I, right? And this also we try to move both I plus plus, j minus. Now what is the other case? The other case is, what if both are not alphabets? Like this. See, what if I is here and j is here? In this case, both are not alphabets, right? This is a hyphen, this is a hyphen. So we shouldn't do anything, right? We should not swap these things, right? We should keep them wherever they are. You may ask, sir, both are hyphens, right? Even if I swap, what is the problem? Well, this is not always the case, right? Here there can be hyphen or here there can be hash. You should not swap hash and hyphen, right? They are saying clearly that non-letters should be present in the same places. Okay. So now let's try to run this. If all of this is completed properly, after coming out of this for loop, you can try to do a return. So you need to return the string, right? So the data type is you need to return the string. So you have character array. To convert character array back into string, you need to create a new string in Java using the character array. Alright. So we are creating a new string out of the character array and then we are returning. Right? So all the test cases passed. Yes, sir. So that is correct. Good. A lot of you are trying reverse only letters. So that's how you can leverage the concept of 2 pointers to solve this problem without taking any extra array. Of course, we had to convert it into character array in Java. There is no other option. Even in Python, you need to convert that into a list of characters. Right? So please note what is happening in these if statements. The first if statement is checking if both are alphabets. There are only 4 cases, guys, in this problem. The 4 cases are, if you want me to list them out, the 4 cases is, first case is array of I is alphabet, but not array of j. This is case 1. In that case, what we will try to do? What is the solution for this case? The solution is, you already know left side you have an alphabet, but array of j is not alphabet, right? If array of j is not alphabet, if you move j, there is a possibility that j also reaches an alphabet. So what is the solution for this? J minus minus. What is second case? Array of I is not alphabet, but array of j is. In that case, what is the solution? See, on the right side you have alphabet now, but on the left side you don't have alphabet. So what is the solution? If you move I plus plus, there is a chance that I may reach an alphabet. Now what is the third case? Array of I and array of j. Both are alphabets. If both are alphabets, then simply what is the solution? Since you only want to swap alphabets, swap and move I plus plus, j minus. Now fourth one is array of I and array of j. Both are not alphabets. What is the solution in this case? The solution is move I plus plus, j minus minus. So in this case we don't swap. See, what is the difference between the third case and fourth case? In the third case we swap because we have to reverse and then move I and j. But in fourth case, since both of them are not alphabets, we shouldn't touch them. So we are leaving them out. Simply moving I and j. How many of you understood this, guys? Is it clear? So did you get an idea on how to solve this kind of problem using 2 pointers without actually having the need to take a new array? Except that one character array you converted, that doesn't count. Okay. So the similar kind of program will be present, which is a little more trickier than this. I will show this, but I will not explain. So this program is called as valid palindrome. So you need to check whether the given string is palindrome or not. But here is the catch. The catch is the string will be given in such way that it could contain alphabets, it could contain special characters, and it could also contain digits. Okay. Now what you need to do is first the given string. So if a phrase is a palindrome, if after converting all uppercase into lowercase, so the string could contain uppercase letters, you need to first turn them into lowercase and removing all non-alphanumeric characters. This word is very important. Non-alphanumeric characters means any character that is not an alphabet nor a digit, which means only special characters and spaces. Alphanumeric means it could be alphabet, which means uppercase characters, or lowercase. Numeric means it could also be a digit. So what does it mean by non-alphanumeric? Non-alphanumeric means the character should not belong to letters category, which means alphabets category, nor digits category. What are the other characters? Well, the other characters is spaces and special characters. And special characters, right? Now what they are asking in this question is, you need to remove all the spaces and special characters. Then first you need to convert uppercase into lowercase. Then you have to check whether it's palindrome. See what is the sentence they have given here? A man, a plan, a canal, Panama. Right? So first let us take this string and check whether it is palindrome or not. So before trying to convert or check whether this is palindrome, according to the problem, what you should do is there should not be any capital letters, which means you have to convert this into small a, man, plan, canal, Panama. In Panama, P capital, right? So you have to convert this into small. Now that is first step, right? First step is converting into all lowercase letters. Okay, this is good. What is the second step? The second step is you should not contain any special characters or spaces. Spaces, special characters. So spaces, special characters, they did never mention about spaces, special characters, right? But this word, non-alphanumeric, means you should avoid spaces and special characters. Alphanumeric means alphabets and digits, both are allowed. Non-alphanumeric means special characters and spaces. So if you remove special characters and spaces, what does this become? A, man, a, plan, a, canal, Panama. Now if you read it backwards, a, man, a, plan, so you can see a plan, and another a, canal, Panama, right? P-A-N-A-M-A. So this is a palindrome. Now you need to check whether the string is palindrome or not, like this, right? So for this problem, at first thought you may think that I need to perform these two steps. First I have to convert all this string into lowercase from uppercase, and then I need to remove spaces and special characters also. But actually it's not required if you use two-pointer technique in a clever way. So what is a clever way? The clever way is we try to only compare the character and another character by ignoring the case. We don't try to compare a space and a character. If a space or a special character is encountered, like a comma, we try to move that particular pointer. If I is at a special character, but J is at a normal character, then we should not consider special characters, right? So we try to move I. So if you use two-pointer technique in the same way you did for finding reversing only letters, you will be able to solve this problem. So I'm going to give you this as a task. So you try to solve it if you have some time. Okay. So this is the problem, valid palindrome. And instead of explaining the two pointers in such way that so far we have seen two pointers in a way that we are keeping one pointer at the very end of a string and we are keeping one pointer at the beginning of a string, right? And then we are moving accordingly. But not every time two pointers needs to be done like this. One example for that problem is this one. So this problem is called as is subsequence. I will also put a link to this problem. If you want to try, you can try immediately. But first, let me explain what this problem is all about. So before explaining this, first let me read out the problem. So given two strings S and T, Okay, there are two strings given for you, and one string is called as yes, the first string, and then t. Now what you need to do, return true. You have to return true if yes is a subsequence of t, false otherwise. So first, if you want to know how to solve this problem, you need to clearly understand what is the definition of a subsequence, right? So first let us take this string, and then I will explain what is a subsequence. Right. So this is the string. And let me write this string as a character array like this. That is A, H, B, G, D, C. So let's write the indexes also. Now, this is our string called T. Okay. Now we have another string that is called yes, right? Now, if you take yes, any string, yes, you can call it as subsequence if the characters present in yes are exactly present in T in the same order, but not adjacent, right? For instance, if you take yes like this, H, G, C, you can say HGC is a subsequence of this particular T. Now, how HGC is a subsequence? Look at here. H is here, G is here, C is here. Now you can see the same letters HGC are present in T in exactly the same order. Same order means H should come first, G should come next, C should come next. I hope you got the point, guys. But for a subsequence, the HGC doesn't necessarily need to be right next to each other. For example, you may argue that, sir, HGCs are not on side by side like this. So can we still say it's a subsequence? Yes, you can still say it's a subsequence, but not a substring. So what is the difference between a substring and subsequence? Well, a substring means the characters should be adjacent. Characters should be adjacent to each other. For example, if you take HGC, you cannot say HGC is a substring of T. The reason is HGC is present, but not right next to each other, right? If you take something like HBG, now HBG is a subsequence. You can see HBG are present like this. So this is a substring, right? So please note that every substring is also a subsequence, but not every subsequence is a substring. I hope you understood the point, guys. So if you take HBG, it is a substring as well as a subsequence also. But if you take HGC, HGC is only a subsequence because H is here, G is here, C is here. But it's not substring because they are not adjacent. How many of you understood the distinction between subsequence and substring? So if you understood this, put in the chat box that I understood. Then I will ask a few questions to check whether you understood or not. Is it clear? Okay. Okay, guys, cool. Thank you. So if it is clear, then answer this. For this given string T, I will try to write some versions of yes here. Okay. I will try to write some versions of yes, and you tell me whether these versions of yes are subsequences or substrings or both. Okay. So first version of yes, AC. Come on. For this string, is AC a subsequence or a substring or both? It's just a subsequence. You sure? Okay. Now what about this? If I try to write DG, is it subsequence, substring or none? Yes, it is none. That's correct. The correct answer is none because there is no such sequence like GD, right? Actually, there is G first, then D, not DG. Okay, what about now? B, G, D. Is it a subsequence, substring, none or both? Right. So that's correct. It's both. So what about now? AH, BC. Yes, it's only subsequence but not substring. That is correct. What about now? AH, BG, DC. AH, BG, DC. Okay. Now you understood the distinction, right? Now that you understood the distinction, let us see how you can tell whether a given string S is a subsequence of given string T. Okay, so let's take the first input. What is the first input here? ABC, right? And you can say A, B, C is here. So how do you say whether it's a subsequence? First, let us take this string S here, and S contains what? ABC, right? That's cool. Now what are the indexes? 0, 1. Now here at first glance this problem looks very difficult, but if you know the two pointers technique, it's very simple. First, you should keep one thing out of your mind, guys. Two pointers technique doesn't mean you always try to start I at the beginning and J at the end, and you always try to move this pointer here and this pointer here. That's not exactly what two pointers means. Now two pointers means sometimes you can try to run the two pointers on two different strings also. For example, here, how do I find whether this ABC sequence is present in T? Well, let us see the technique. The technique is, let us try to take one variable I which runs on S. Okay, and let's take one variable J which runs on T. Now what I will try to do is, whenever I started running the loop, I will try to check if the character that is present at ith index in S, which is A here, is equal to the character that is present at jth index in T, like this. Now why am I checking these two characters? Because I know that if it has to be a subsequence, at least one of this character, one version of this character should be present in T, right? Correct? Now you can see A and A are matched. But we cannot say just because A and A is matched, ABC is a subsequence of T, because we did not check whether BC is matched, right? But at least for A it is matched, right? Now in this case, I will try to move J. I will also try to move I. You got the point, guys? But now see, you will try to compare, to do the same thing. Compare the jth index value in T to ith index value in S. So what is the comparison? I'm comparing B and H. Now think about it, guys. B is not equal to H. So please note that just because B is not equal to H doesn't mean you can say this is not a subsequence. Remember what subsequence is? In subsequence, the characters doesn't need to be adjacent. They have to be in just the same order. That's it. So here you're not going to conclude that just because B and H are different, that doesn't mean ABC is not a subsequence. What you will try to do is, you will try to move only J. Why? Because yes, this B is not found here at first index, who knows, maybe B will be there in second index. Then also it will be a subsequence, right? Or maybe B will be found in 7th index, or maybe B will be found in 10th index. I don't know, right? That is why when the match is not found, we are not going to conclude that it's not a subsequence. Rather, we try to move J. So we try to move J, hoping that we will find this B somewhere, right? Unfortunately for us, B is here, right? But by the time B is here, please note that you did not move I. I is still at B here. So B and B are matched. That means up to this point, it's a subsequence. Okay, but still the story is not completed. The reason is we are still have to explore some more characters in T, and we still have to explore some more characters in S also, right? But here is the story. The story is, since B and B are matched, we move J and we also move I. Now we are looking for C and C to be matched. Here G and C are not matched, so we don't get discouraged. We will just hope that somewhere in between or somewhere in front we will find C. See, D and C are not matched, and then we will go here. And C and C are matched. When C and C are matched, we will try to move both, right? We try to move J as well as move I, right? But here is the stopping point. Why the stopping point? We explored all the indexes present in T, and we explored all the indexes present in S. So there are no more indexes to check, so the loop stops. So up to which point you have to run the loop? You have to run the loop until J reaches the end or I reaches the end, which means as long as I is less than length of S and J is less than length of T, we can do this. But after coming out of this loop, how you can decide whether you found the subsequence? It's very important. If you found the subsequence, currently look at I. I is at which index? Third index, right? Actually, there is no third index, but if you do plus plus, I becomes 3. That is the length of S, right? So if your I value reaches length of S, that means all the 3 characters are found, or all the n characters are found, right? If all the n characters are found, definitely S is a subsequence of T. Guys, you understood this one? How we are saying whether this is a subsequence or not? I hope you understood the point. So I will try to explain this again. What happens if I try to check whether a subsequence of T is nothing but an S like this? Let's take an S and let's say the S is nothing but A and Z, right? If A and Z are there, only 2 letters are there. What is our technique? Let us recall the technique. The technique is I starts running the loop on T and J starts running the loop on S, or you can reverse this. J is on T, I is on S, it doesn't matter. Now we are going to compare S of I with T of J. If both are same, at least there is a chance that it could be a subsequence of T, right? So we are not counting out that fact, and we are moving both I and J. But look at here. So whenever a H is found here, you compare it with Z. Z and H are not same. Hopefully you will check B. B and Z are not same, and you will hopefully check G. G and Z are not same. D and Z are not same. C and Z are not same. So J reaches to the end, right? So which means the J loop is over, but you still did not find the subsequence Z. Z is not there, only A is there. But that's the point I'm asking. How could you know that this subsequence is not found? You can simply see that if the subsequence is found, you will also would have come past this first index, right? I comes here. But if still I is here, that means only some of the characters are found, but not the others. That is why after coming out of this loop, what you will check? You will check whether I reaches length of S. Then it's true, otherwise it's not. You understood, guys? Is it clear? So I'm going to write the code for this and I will end this session. So what we will try to do? So the 2 pointers doesn't mean you always try to run the loop on one string, guys. It could be sometimes running the loop on 2 strings or 2 arrays also. So let us see. First I am trying to take I, which starts from 0, and j also starts from 0. But the only difference is j is to run a loop on t, but I is to run a loop on s. So what is the condition? Here you should not check I less than j, because both I and j are not running on single loop, right? Sorry, on single variable. They are running on different variables. So the condition is as long as I doesn't reach s length, right? So I less than length of s and j less than length of t. So this is our condition, right? Now what we will try to do here, the story is we are going to check if s dot caret of I. So which means the ith index value from string s, whether it is equal to jth index character in string t dot caret of I. If both are equals, there is a chance that it could be, which means the s could be a subsequence of t, right? So we are trying to move I plus plus, j also plus plus, not minus minus, right? Now, what is the second case? The second case is they are not equal. If they are not equal, we are hoping that maybe if I move my loop on j, maybe in the further indexes, I will find a match to ith index character in s, right? So I'm only moving j, that's it. So after coming out of this loop, we are going to simply return if I is equal to s dot line. Let me run this. Okay. J less than t dot length. Okay, it's not t dot caret I, right? Here we have to check caret j. So let me run, and you can see both test cases is passed. Is it understood, guys? Or is it confusing that why I had to write I equal to s dot length? You got the point why we have written it like this? Clear, right? Okay. So you also try this problem. It's a link in the group, right? And also try the other problem I sent, the valid palindrome or not. And we will meet in tomorrow's class. So please note one thing, 2 pointers doesn't always mean you try to run the loop forwards and backwards, right? To solve a problem like this, C subsequence also, you can use 2 pointers. If you look at the tag of this problem, it will contain 2 pointers. Right? So I hope it is clear. So thank you for attending today's session. We will meet tomorrow again. Have a good night, guys.
వచ్చేస్తుందా ఇంకా ఇయ్యా. అమ్మ దుప్పటి తీస్తున్నానే అన్ని కోటి నీ కోటి కొంతగా ఎలా తీయాలి పంపుతాడంటే ఈరోజు ఏంటి కదా
తమ్ముడు ఉన్న చాతలేక తమ్ముడు తమ్మ
ఇది కొంచెం మీద ఉంటుంది చూడు కాకపోతే లగ్మని పొడి